Hey everybody, quick video. I am doing a little brainstorming here with my friend, and I happen to be just driving down the road, and it kind of came out of the blue with my answer, solution, and why something happened today. And let me explain. As you can see, the title of the video is Natus Warm Lamp 45 Troubleshooting. And typically you're going to have 3 heating elements that go bad on them, and you can see that they start to turn color or whatnot. And most of the time, if you don't know how to troubleshoot them, this will be the start of troubleshooting them. So we're going to go, and I have not really searched much for this, and I don't know if there really is a wiring diagram or a service manual for that. So I'm going to kind of do a very basic wiring diagram for you. We'll do it in live time, in real time. And I haven't sketched this out before, just 2 blanks, a piece of paper, and I'm just going to do it off the top of my head. So you're going to have 3 wires coming in. You have your black wire, your white wire, and your green wire. And this is all part of your troubleshooting. And I will take in just, we will, I'll make a sketch of the lamp, of what it looks like. That's going to be a big square thing here, plus a little light on the side. You have a big box in the center. That's your lamp, okay? That's what it looks like. So, if you have no power whatsoever, the bulb don't work and the heat doesn't come up, you have your main power comes here. And you have a power cord going to here, and then you have a power cord going from here to your lamp. We'll make little lights there. This is going to be a little square guy here with 3 bulbs inside of it. So typically what you're going to find is no power to these, nothing turning on. Check this outlet plug here. 9 out of 10 times staff have already broke the ground prong of the power cord, and so that plug is already been replaced. And what happens over time is they are just yanking it by the cable, and a screw's gotten loose, and now everything's heated up, and now you've lost connection. So check that plug. 100%, most times it's going to be that issue. Plugs. Okay? If your light works and your heating element doesn't work, 2 possible problems. Could be 3, but 2, ultimately, I see these 100% of the time. And this one actually, this is the second time I've seen this one issue. So we'll flip onto another page. Hopefully he's keeping up here. And we'll draw a bigger picture of the box, and we'll mock 2 elements, or there's 3 heating elements inside, right? And so they have, there's your heating elements, and so they have a couple of bus bars. You're going to have 1 wire coming in on one side, and it's going to be red, and we're going to have just like 2 little things you'll see here in just a minute. And then the other side is a gray wire. Okay, and so let me think this. The red goes to here, the gray's there, so we're going to do this to that. So they made these heating elements into series, okay? And so most heating elements like that are made from nichrome wire, and so they have a resistance to them. And so the nichrome wire on on 3 of these should be about 7.6 ohms. Okay, so if you measure across these 2 posts here on each of the heating element, you should measure 7.6 across each one. Or if you go across there, you should be about 22, 23, 24, 25 ohms. If you go higher, say it's like 70 ohms or 400 ohms or whatever, you can go and measure across and you know which heating element is bad. So if you're going to replace one, you should just replace them all 3 at the same time. Prevent the next work order too much down the road or whatever. So you're preventing maintenance happening later on. But if you're on a tight budget and you just want to replace the one, because they're like $500 for a heating element or so, then just replace the one. But that would be the easiest way to take and measure it. It should be like 7.6 ohm. Spot on. Don't flinch if it's like, 7 ohms or 8 ohms. It's fine. It's going to vary just a little bit. Your meter is going to vary from my meter. You might be using a different meter than a fluke meter. So just know what you're measuring. Go across these 2 points here and you should get a little ohming. I'm not saying 0 ohms. You should not have 0 ohms. It should be like 7.6, 8 ohms, 10 ohms maybe. That's a little high. But that is one problem to your deal. Today, I experienced for the second time in 5 years another issue. So, troubleshooting with the guys at work, with the newer guys, and we put a meter lead here and here. So we know this is AC going into this. So we should have, red would be positive and gray would be negative. And we had 0.964 volts AC. Okay? Can you tell me why we had 0.0946 volts across this circuit here? If you guess because it's just measuring the voltage drop, you're absolutely right. And I didn't think about that until 10 hours later. I'm driving down the road, and I'm listening to a band named Tool, and we're going on a trip. And I love the drumming part of it because it makes me focus, stop falling. I know, you're just dead inside. Okay, focus. Anyway, so that's why we only measure that, because we're doing across it's measuring series resistance. Consider these resistors here. That's all they are. If you think about it, they're resistors. These heating elements are resistors that you can see through. Most resistors have a ceramic coating on the outside, so you can't see those swirly little things that there's inside there, the coils. Now you can't. If you vision that in your head, that's a resistor. And that's why you're measuring 7.6 ohm exactly. Because that's what it is. Okay, so back to this. 0.96 volts across here. And so, okay, that's kind of weird, right? And we weren't getting 120 volts going to the red at all. We were not getting 120 volts in reference to a ground wire, the green wire, which is tied into your box to your white wire. So, kind of go back to electricity, how electricity works. Your neutral and your earth ground are tied to the same spot in your circuit breaker. That's how it works. Green wire is just a safety wire in case the white wire breaks and you need to have a path to current to go to ground. So, I used the green wire for reference, and I had 0 volts going on the red and the gray, and I'm like, what the heck? So the gray wire, if you follow it back, the gray wire goes back up to this little sleeve, and there's a fan there, okay? And we'll draw this little fan, and we'll just name it fan. And behind the fan, it goes down below, and then back out. into it's the same gray wire, a second gray wire, and it goes to a black wire here. And I'll label that black. And I think the number is 13, could be wrong, don't quote me on that. And then, so the red wire goes to, there's we'll make a little thing over here, and I'll describe it in just a second. So, red coming off the heating element, and then gray. So you have a reference of what I'm talking about. You know, it's not like, hey bro, calm down. I know you want to see it. Okay? So, the gray wire coming from the heating elements right here, going up to the sleeve. Inside the sleeve is a temperature sensor. It's not a thermal cutoff, it's a temperature sensor. Okay? And then from there, it goes back down to the black wire. That black wire goes back to your rotary switch, your timer. Okay? So there's a timer on the big box, and that timer has two switches, one for neutral, one for hot. So, that's your neutral. That black wire going to that gray wire is your neutral. Alright, hopefully you follow me. So that's your neutral. You can use that for your reference. This red wire goes up to the thermal cutoff switch up here, which daisy changed back to this other thermal cutoff switch on the right side, which goes down to, it's a red wire, which goes to another black wire. So that's your 120 coming in here, and that's your neutral. Okay, so logically we got that going. And I'm like, okay, so I unplugged this and this from your heating element, and I measured 120 volts. I'm like, huh, I have 120 volts there. I measure this and this thermal switch, and they're 0 ohms. I'm close to it. I measure this thermocoupler, and that's 0 ohms. I'll make a little horseshoe. So they're all 0 ohms. They're good. They're providing a path to voltage. So I took in knowing that this is your hot, and I know the heating element to going through here, going to neutral. I put my meter lead from here to here, and it starts emitting heat. That should clue you in to why we already have an issue. So I was able to trace back all this. I can verify that this has 0 ohms here, this has 0 ohms here, but I had to, in order to figure that out, I had to go from this gray wire to this wire here and see that that's working fine. So I know the wiring here is fine. I was able to trace this wire to here, to here, to here, to here. I can visually see that. So I went from here, going into the thermal, to the gray wire, and I had 74 volts. Now you might be wondering, why only 74 volts? You measured it's 120. We also had the intensity pot. It's down below the timer switch. The intensity pot now in the circuit, and it's bringing it down. You're also using your voltmeter as a path through this. Hope you're following. So it's kind of just when you think about it, you look at it and you go, okay, that makes sense now. So 74 volts is what you will measure, because now your intensity pot, the potentiometer, you're putting that in the circuit, and now it's lowering it down your voltage. Like, okay, so then I measured from the black here to the switch here, the thermal cutoff here, and I have 0 volts. So I know that this connection here, it's good. I can pull on it, it's tight. This connection up here, for whatever reason, this is the second one in 5 years. It's a thin wire, and it breaks at that post. and I was just driving down the road and I thought of that. If you have any questions, I hope this helps. And that's my troubleshooting for the Natus. Hopefully they're not dead inside like Buddy here. Thanks for watching, guys. I hope this helped you out. We'll see you next time.